Hey guys, so this is another video over the week. So this is over eccentricities. Really the only ones you're going to need it for is for an ellipse and a hyperbola. And really this is just the ratio of the focus length to the major axis, whichever it may be. Okay, so focus to the major. So what you should know is that an ellipse, guys, it's always going to be between 0 and 1. Okay, which makes sense because remember the focus here is going to be smaller than the major. So your ratio should be, less than 1. Okay, so using these, again, this one was for a hyperbola, I'm sorry, and for an ellipse. Okay, remember this is a ratio between the focus and the major, so C and A's. So here, the A was the biggest one, so an ellipse, it should be smaller than 1. And since the C value, the A value is smaller than the focus length in a hyperbola, it should be greater than 1 for a hyperbola. And so that's all this is measuring. So it's going to already, a lot of this is going to be depending on, like, can you tell what shape you have, okay? And so, well, I should have worked this out over here, but that's okay. So if I look at this, guys, remember I can tell this is an ellipse because there's a plus sign between the two. So these are both positive, okay? When I see a negative sign like I see over here, that means I'm dealing with a hyperbola. So identifying the shape is going to be important. Okay, so here, remember, for an ellipse, the A value is the bigger one. So here, my A squared value is equal to 100, right? That's the bigger number here, which means my A is equal to 10. Now I can find, and my B value is equal to 5 because it is square root of 25. And I can find my C value here because that's what I need for my eccentricity by using this relationship. So 100 plus C squared equals 25. I'm sorry, this should be the other way around. My fault. So if I subtract 25, my C squared value is equal to 75, so my C is equal to the square root of 75. So, to find my eccentricity, guys, is just C divided by A. And so this is the square root of 75 divided by A, which is 10. Okay, and so you would see if I actually divided that, okay, the square root of 75 divided by 10, oops, let me do that again. Is equal to, it's equal to the square root of 3 over 2, which I'm not sure why this is not giving me a... It's not giving me a decimal. Okay. That's okay. I have the other calculator here. I guess I should have got that one. So the square root of 75 divided by 10 gives me a value of 0.866, which, guys, this is a ellipse, so it should be less than 1. Okay. Now I'm going to do the same thing here. Now I do know it's a hyperbola. Again, I see the negative sign. And my A value here is 6, right? Because this is the positive one. So this is my major value. And I can find the C value using this relationship for the hyperbola. Remember, the B is equal to 9, and in this I need 9 squared, so it's 81. C is equal to the square root of 117. So the eccentricity, C divided by A, is equal to square root of 117 divided by A, which is 6. So that equals, if I were to do that in the calculator, 1.8, which makes sense because it should be greater than 8 for a hyperbola. Okay, so the next thing that I'm going to do here, guys, I'm going to convert these into general standard form. So this is just another thing that they're going to ask you on the test. So right here I have standard form, but to turn it into general form, by the way, that was up for eccentricities. This is what I would do, okay? And so general form just means something like this, okay? And I mean, it's not hard. It's just, it takes a while to do. So here, what I would do, guys, is, and the numbers won't be this big on the test, just so you know. I cannot add these two values because I have different denominators. But what I could do is, if I said I multiplied this value and this one by 121, right now there's 100 down there, and I multiplied this one over here by 100, then I would have the same denominator, and then I could add the top parts. Now I'm going to go ahead and just multiply 121 times 100, which is, whoops, pretty big number here. Okay, and, sorry. So, to get rid of this part, I would multiply by this to cancel it here. When I do to one side, I have to do to the other. So I'm left with this right here. Okay. So, what I'm going to do here now is I'm going to do the FOIL. So, guys, I'm not going to make this its own step. I'm just going to tell you what this is. So if I did FOIL, x plus 3 squared, x plus 3 times x plus 3, this is what I would get. Oops, this should be a y. And when I distribute, this is 121 x squared plus 121 times 6. That's going to be a big number. We'll find out what it is right now. Oops, calculator's off. So 121 times 6, 726. 121 times 9. Okay, and then I'm going to do the same here. So plus 100y squared plus 600y plus 900 equals 121,000. So I'm going to reorder this. So remember, usually we see it with the x squares in the front. Okay, and what I'm going to do is combine like term. This is a single number. This is a single number. And what I'm also going to do is bring this one over here. So I'm going to subtract 121,000. So they cancel over here. So it's 0, and then bring it on the other side. So when I add these three numbers, 1089 plus 900 minus 121, or excuse me, 12,100, I get this right here. So that is my standard form there. Okay, so went ahead and worked this one out as well. So you can check yourself. Okay, so you have another example. Just be careful because when I distributed this is an ellipse, by the way, because it has that negative sign. Don't forget that you are multiplying the negatives when you distribute, and so signs change a little bit. Again, numbers won't be that big on the test, but please just look for them. Okay.